This is our introduction to Math 146, which is Introduction to Statistics. And this video is being made in Scotland, which is the reason I'm physically not with you for this week. I will be getting a return flight at the end of the week, and I will see you on Monday. So on Monday the 9th, classes will take place in the normal way. So what I want to do today, on this video at least, is go over a little bit of an introduction, go over the syllabus, tell you a little bit about myself, and get us prepared for the lessons that are going to take place in the coming week and what's expected of you during that time. So I should introduce myself. My name is Donald Robertson. As you probably can tell, I'm Scottish. I'm home visiting family. We have some health issues as well that members of my family are going through, so that's why I'm here. And I was born in Scotland. This is actually my 42nd year of teaching. So I've been doing this for quite a while. And the class that we're going to be doing is Introduction to Statistics. So let me give you a rough idea what's going to happen over the coming 10, 11 weeks. I think the first thing we need to do is actually talk about what is statistics. Well, it's there are many definitions, but this is my definition. It's a study of information. Now, information takes a lot of different forms. Information is very often called data. So it's a study of data. And that information, although exclusively, but for the most part, tends to be in the form of numbers. So we go out there and we collect some information. Maybe it's a group of people that we're interested in, and we're interested in certain variables associated with these individuals. Maybe we're interested in their age and their weight, or maybe we're interested in the amount of education they've got and actually how much money they're making. And we can take this information and we basically go through a process. The first thing, not surprisingly, is that we need to collect the information. So we need to collect the data. And we will deal with issues. How do you collect good data, right? We would call that unbiased. How do you collect this unbiased data? And how much of that data do you need to be able to actually use it? I mean, you couldn't go out and just ask 2 people something. I mean, technically that would be collecting data, but I wouldn't want to make any inferences about a general population based on the only 2 people that I talk to. Right? And also there's things to do with if you're asking people questions, right? You want to make sure that you get truthful data. You also want to make sure that the data is a fair reflection of the population. That's the group of people that you're interested in. And so there's a lot of stuff goes on in that, and we'll deal with some of the problems and some of the solutions to how to collect the data. Now, once you've collected the data, it's quite typical that you summarize this data and that you find ways to visualize it. So we would then go and look at summarizing the data and visualizing it. This data. Summarizing it would be things like, okay, you've collected, I don't know, the ages of 1,000 people at Olympic College. Well, you could just give someone a piece of paper, and on that piece of paper, or papers probably, you needed more than one sheet, you've got the ages of every single person that you talked to. Well, that wouldn't really be very helpful. And so you would find some particular numbers, we call these numbers statistics or parameters, depending on their context, that kind of summarize that data. And the types of things we might say is, look, oh, when we found the mean of them, the mean age was 23. Or we might find the standard deviation, which is a number that tells you how spread out the data, and it was 5 years. Or we might tell you the quartiles, which basically tell you at what age the first 25% of them are, the 50th percentile, the median, the 75th percentile, and so on. We would give you numbers that you could use to summarize it. We could also summarize it by putting the data into tables, charts, and various kinds of diagrams. And that would be under the visualization situation. So we'll find in this class different types of tables. You could have frequency tables, relative frequency tables, grouped frequency tables. What kind of charts could you have? Well, you could have bar charts, pie charts, scatter plots. What other kinds of diagrams could you get? Well, there are lots of them. There are things called stem and leaf and box plots and all sorts of different things. And that's just another way of visualizing the data. My apologies. I actually have managed to pick up a bug in Scotland, so from time to time I'm going to be coughing. I should apologize for any distractions that might cause, but it's bound to happen as I talk. So that would be the second thing that we would look for, right? Now, what would the third thing be? Well, we've collected the data, we've summarized it and visualized it in various ways to make it easy to see what the data is telling us. And the third thing that we can do is we can use it to make predictions. And that's a very big thing that is used a lot in statistics, where you've collected data and then you use it to predict. So let's suppose I collected 1,000 OC students and that the mean age was 23. I could use that reasonably to predict that the average age of all OC students is 23. But it would be nicer if I could say to you things like this, that I'm 90% confident that the mean age will say 23 plus or minus 3 years. So that would be an example of a prediction. I'm saying, okay, the 1,000 that I asked, it was 23, but there's 5,000 people at OC, so maybe I got a little bit unlucky and there was some older students more than you typically would expect, or some younger students, right? It'd be a little bit off. It's bound to be a little bit off because I haven't asked everybody. But in this sentence, what I've been able to do is tell you that somewhere between 20 and 26 is the exact value for the average age of every single OC student. So if you found all of them, got all of their ages and found the average of them, it would be somewhere in that range. But we're never in statistics. I can't emphasize this enough. We are never going to be 100% sure of anything. There's always that, well, for want of a better term, bad luck influence. You know, you do everything right, and then just with bad luck, you just got a bad sample, right? It just works out that way. So that's what that's saying. And that's saying that for this type of prediction, 90% of them that I did, the interval I give would work, right? The real average would definitely be in that. But there's a 10% chance I got it wrong. Now, if you can pretend that I went and said to you that I was 99% confident that it was in this range, well, that would basically mean that I'm not 100% sure, but would you agree that there's a very small chance, a 1% chance, that the real answer is not in that range? And so that's very helpful. When you give someone a prediction, it's very helpful to put this number, and we'll find out how you create this number, and we'll find out how you create these intervals during this class. And though those confidence intervals, as they're very often called, are very helpful in you deciding whether or not you want to bet your house on that answer, right? On a 90, I'm 1 in 10 chance of being wrong, and a 99, I'm 1 in 100 chance. I'm pretty sure that if this was one, I'd be pretty good at saying, yeah, I'm sure the answer is in that range. And the last thing you use is you use it, the data, to test a theory. We don't use the word theory, but another word for it is we use it to test a hypothesis. So maybe your theory is, I think more men than women like watching horror movies, right? More adult men than women like watching horror movies. That's my theory. I would then like to test it. And I would go out there and I'd get a random sample of, whatever size I can afford, 2,000 people, adults, 1,000 males, 1,000 females. Ask them if they like watching horror movies or not. And we'll keep it simple. They can only say yes or no. And then I can take that result and I can do some statistical analysis on it, a test. And if I get good data that is significant so that there is a difference that can be measured and replicated, then I can then, like in a court of law, say, I have now proved that men like it more than, going to the movie or whatever it would be, than the women do. And you can use this in scientific analysis, right? I'd like to prove a certain theory is correct. How could I go about that? Well, we would say, let's test the hypothesis. Let's test your theory. And that's kind of the overview of what this class is going to look like.